Hi everyone, welcome to the another day in our AI course. So today we are going to discuss about Python operators. Okay, so we'll be discussing about arithmetic operators, comparison operators, logical operators, assignment operators, the identity operators, membership operators, and operator precedence. So each section includes syntax, basic examples, and MLOps real world examples. Okay, so again, arithmetic operations, these operations you may know already or you may not know, but just to complete, just to keep things simple, just to um, keep things same as for everyone, that's why I'm continuing in this way. Because for someone who is very new to Python, for them maybe this part is not yet clear. Okay, so that is why you are focusing on that. So we'll be starting with the arithmetic operations, and slowly we will complete all these sections. So you can see in my notebook all these things are mentioned. I will be completing that, and this notebook is not that big. Okay, and this topic is a bit easier than any other topic that we discuss in Python. So mostly I believe this notebook we can complete very easily. So I guess this day will be very easier and faster for all of us, but still I'll try to give you multiple examples so that you understand everything properly. Okay, so let's start the arithmetic operators. So in arithmetic operators we used for mathematical calculations, the foundation of every ML computation. So whenever do any kind of machine learning computation, you need to do arithmetic operations, right? So that's why we are discussing about it. So again, this sign means addition, like 5 plus 3 8. This means subtraction, like 5 minus 3 2. You need multiplication, 5 multiplied by 3 15. You need division. Again, we have two types of division there, division and float division. So when you use division, right, so you always get the output in a floating point number. Okay, but if you do float division, you'll always get the output in the integer format. Okay, modulus will return you the remainder always. So like 5 modulus 3 means the remainder will be 2. Then exponential, so 5 to the power t 3 means 125. Okay, so let's see that in action. So this is the addition operation that we are discussing, simple addition operation we are discussing. So a equals to 15 and b equals to 7 we have defined, right? Now then result equals to a plus b. So, and again I am using f string to do the formatting. So if you haven't watched the previous recordings, please make sure that you watch that, because there I have discussed about this f string if you don't know about that part yet. Okay, great. So if I execute this code, you will see the final answer coming as 22. Okay, so the next one, addition with different data types. So here we are doing addition with only same data types, like integer plus integer. But what if we do it for integer plus float? So answer will always be in float. Python auto converts it. So you can see print 5 plus 3.2, I get 8.2, and if I check the type, it will always return us as a float. If you see here 8.2 and class return as a float. Again, you know, right, I had discussed in the previous recording also that string concatenation you can do using plus sign. So here you can see one example, first equals to ml, second equals to ops. So if you do first plus second and these two are string, right, so it can be concatenated. See, the output is coming ml ops. Okay, likewise you can concatenate to list also. Again, what is list we discuss later, but just for your knowledge for now, list is something which we denote with this square brackets, and inside the square brackets we provide the values with commas, like 1 2 3 4 5 6. Okay, so I created two lists, list 1 1 2 3, list 2 4 5 6. Again, inside list you can pass strings, boolean, numbers, integer, float, anything if you want to pass you can pass inside this one, but just for demonstration I kept only numbers inside this list. Okay, so if I execute this code, you will see the final print we got 1 2 3 4 5 6. Okay, now below, so there's something on mlops example. So what is mlops and already discussed later, but just for some demonstration I am showing it to you now. So let's say my run 1 accuracy I got 0.89, run 2 accuracy I got 0.92, run 3 accuracy I got 0.91. So what is the total accuracy? So I am doing simply run 1 accuracy plus run 2 accuracy plus run 3 accuracy, and then I am calculating the average of the accuracy, that is total accuracy divided by 3. Why 3? Because I have these 3 accuracies, run 1, run 2, run 3, and if I print at the end, I get the accuracy 0.9067. So again I am showing this whole printing using f string. Okay, so you are good with this addition operation. Okay, now let's talk about the subtraction operation. So what we do in the subtraction operation? So you can see in the for the basic subtraction, what we are doing, we created one variable a equals to 20, b equals to 8. They are simply printing a minus b. Okay, so if we again reconnect, I believe now it should work. Okay, so if I really execute this now, we should get the answer. Yeah, see, we are getting the answer 20 minus 8, 12. Then print 5 minus 10 minus 5, and unarray minus. If you want to do that, we are able to do that to here. Okay, so now let's discuss about one technical example. So the actual price is 45 lakhs, actual house price, and let's say model predicted 437500. Okay, this is what model has predicted. So if I want to calculate the error, actual price minus the predicted price. Okay, so and then I'm using ABS. What is ABS? It will give you the absolute error. Okay, it will give you the absolute error, and we're assuming that we are showing the output in dollar, that is, we are showing output in dollar sign. Okay, if we execute this code, we get the answer. See, prediction error $12,500, and for the absolute error we got same amount, and here we calculated the error percentage. What we did, we divide the absolute error with the actual prices, and then we multiply that with this 100. Okay, and then you know, right, this 2f means I want two decimal numbers after my decimal point, right? So this formatting we already discussed in our previous session. So if you haven't watched that, please you watch that recording. Okay, so this is the output that we are getting. Now next example is about multiplication. Again, you can do multiplication between two integers, you can do multiplication between floating and integer. Okay, same you can do that. So if I execute this code, you can see I am getting 42 and 10.0. So it has multiplied 2.5 with 4, so you got 10.0. Okay, now if you want, you can repeat string using multiplication. Okay, so what I am doing, I am simply created one string here equal to then dash. Okay, now I am multiplying this string with 20. That means this thing will be repeating 20 times, like it is repeated here. Okay, then if I want, I am multiplying this docker text into 3 times. See, I am getting docker text in 3 times. Then what I am doing, I am repeating a list. If I want to repeat a list, again I have not explained you the list yet, but same example, you know, right? The list can be defined with square brackets. So inside our square bracket we kept only one number, 0, and we have multiplied that with 5. So when we had multiplied that with 5, I got 5 numbers, 5 zeros I got. Okay, so this is the example of multiplication. Again, some example of our machine learning part. So let's say my GPU cost per hour came 3.06. Okay, my training hours was 48, and I did 5 number of experiments. Okay, so what will be my total cost? So my total cost will be GPU cost per hour, that is 3.06, multiplied by training hours. Okay, so I did 48 training hours multiplied by number of experiment. Okay, so this is the total GPU cost that I'll be getting. See, I got the GPU cost nearly $734.40. Again, I am using formatting here, that is why you are getting two decimal points. Okay, right. Now let's talk about division and float division. So again, I have told you already, if you do the division with a single slash, okay, with a single slash, then you will get the answer in a floating point number. If you do double slash, you will get the answer in integer format, right? Here what I am doing, 10 divided by 3. If I do that, I got the answer 3.33335. Okay, and if I do 10 divided by 3, I get answer 5.0. Still a float. Why? I have told you already that when you do the regular division, you will always get the answer in a floating point number. If execute this code, you'll get the answer. See, I got 3.33335. I got 5.0 for this much, and I check the type also. So the type I got float here. Great. Then I have printed a dash just to show that it is separate. So this dash is coming here. Then what is saying float division. So it drops the decimal part. So whenever we do float division, it drops the decimal part. So 10 float division 3, I got 3 because in general I was supposed to receive 3.33335, but it has truncated the decimal part. It kept only the integer part. Likewise, it is doing for this division, which is 5, which is actually okay because 10 divided by 2 will always be 5, right? Then negative float division. If you want to do negative float division, you can do that too. You can see 7th float division 2, I got the answer 3. Though it should not be 3, it should be some decimal point number, but again we are doing the double slash of float division, that is why it is coming as 3. Now if you want, you can do negative division 2, like minus 7 divided by 2, you get the answer as minus 4, not minus 3, because it flows towards the negative infinity. It always flows towards the negative infinity. That's why instead of minus 3, you will be getting the answer as minus 4, which is very unique thing. Okay, you are supposed to receive minus 4, right? But you will be getting minus 3 because it flows towards the my bad, you are supposed to get minus 3, but we are getting minus 4. Why? Because it flows towards the negative infinity. That's why. Okay, I hope it is clear. Now let's talk about another example with some machine learning touch. So let's say you have a total sample 10,000 total samples, okay, and you have batch size 64. So if I need to calculate the full batches, then what I need to do, I need to divide the total samples divided by batch size. Okay, so how many complete batches, and then leftover samples, how many samples will be left over. So what I am doing, total samples modulus batch size. So this will give me samples in the last partial batch, and now I am simply printing the total samples, batch size, full batches, leftover samples, and this is the thing. Again, this part I will remove right now because this is a comparison operator I have used here. I will discuss that in the next day. Okay, again, this is the final output that we are getting. Total samples 10,000, batch size 64, full batches 156, leftover samples 16. Okay, so this is one of the example of division. Again, why I am showing you multiple examples, because I know you can do division, multiplication, okay, subtractions, right? But these examples will give you the more perspective on machine learning, because our main course is related to AI, right? AI ML, right? So I just try to give a AI ML touch while explaining you this topic, so that slowly you will be habituated with these terms like total samples, batch size and all, because this all will be coming up when we will be doing end-to-end projects, or we will be discussing about any kind of algorithms. Okay, so yeah, now modulus. So again, modulus gives the remainder after division, we all know that. So now if I do 10 modulus 3, I get 1. Okay, if I do 15 modulus 5, I get 0, because 15 is divisible by 5, right? That is why we get the output as 0. Then 7 modulus 2, we get 1. 8 modulus 2, we get 2, 0. Okay, and again, I'll not show you the even and odd case, because I will not show you that, because again I have used some if else condition code here, which I will not explain now. I'll explain when it will come. Okay, so this is the output I am trying to show you. Okay, again I think this pudding itself is not required. I just remove this one. Okay, this is the output that we are getting below. Okay, now next, again some ML example. So let's say what I am doing. I am doing total steps 100 and log every 10 seconds. Okay, so total steps 100 and it has to log in every 10 seconds. Again, if this is a loop example and you don't know about loop yet, so again I will not deep dive much about loop right now. I'll just explain what is happening here. Then later on, after this recording, the next day that recording we get, right, there we discuss about loop and everything. Okay, there you will get more understanding about that topic, but just for now I'll explain this. Okay, so what I'm doing, I'm running a loop in some range. So I'm running a loop, simply it means that I'll go through one iteration. Okay, So how many times I will do it? 1 comma total steps per 1. That means 1, it will start from 1. How many steps I have? 100 steps. 100 plus 1, 101, right? But it will run from 1 till 100. This is the way how Python works. Why it works, I will explain when we talk about loop, but this is how it will work. So it will run 1 till 100, okay, and then what it will do, it will calculate the loss. How it will calculate the loss? It will calculate the loss like by 1 divided by step to the power 0.5. That means root step. Okay, what will be the step value? 1 2 3 karke till the 100 we get it. Okay, so this is fake decreasing loss. We are just creating one calculation where it will be showing is decreasing the loss. So then we are checking if step modulus log every, that means only print every 10th step. That means whenever it will divide like the number that we get in the steps, right? 1 2 3 till the 100, right? So whenever we try to find the modulus with 10 of that number, and if that is 0 coming, then that means that is the 10th step of the specific loop, right? From 1 till the 100. So on that time it will print the number. That's all. If you see in 10th loop it is showing if the loss. So again, this is a simulation that we created. So this is how it will look like. So this kind of operation we will be doing in the future. So guys, you can see this thing, right? Step 100, step 10, step 90, step 40, right? So whenever we do the deep learning part, right, on that time you will see these things. Okay, that's why I just wanted to give you the idea about it at the very first time only. Okay, now the next thing is another example. Okay, so again I will not explain this example because this example also has a loop, and I don't want to explain loop right now because you don't know about loop much, so I will not emphasize loop a lot in this video. Okay, great. So now we'll talk about the exponential. So what happened in exponentiation? So again it means to the power. So 2 double star 3, that means 2 to the power 3, that is 8. 10 to the power 6, that is 1 lakh or 1 million, I guess. Yeah, 2 to the power 10 means 1024. Okay, then square root. See, you know, right, how to calculate the square root mathematically. So root 144, root 144 means what? Root means 1 by 2, and 1 by 2 means what? 0.5. So 144 to the power 0.5 means root 144, and you know, right, what is the square root of 144? That is 12. Okay, that is what we are printing here. You can do 2 to the power 0.5. So the square root of 2 value is 1.4142. If you want, you can do negative exponents also. 10 to the power minus 3, that will be 0.001. So if you execute this code, see, you are getting all the answers as mentioned here. Okay, now another machine learning example. The initial learning rate is 0.01. What is learning rate? You don't have to know right now, but think of it like some learning rate. Okay, some value which will be changing in the future. Okay, so initial learning rate 0.01 and decay rate 0.95. So we are running a loop from 1 till the 10 because I have mentioned it will always subtract 1 from the end. So we are saying 1, 11, that means start from 1, go till 11. Okay, and then what we will do, it will do some calculation. Initial error multiplied by decay rate to the power epoch. Okay, so what is the calculation here? Initial learning rate 0.01 multiplied by decay rate, that is 0.95, to the power the epoch, that means 1 2 3 till the 10 value. Okay, and it will simply print that. Okay, so you can see in the first epoch we got the learning rate as 0.0095. In the second we got 0.0090, and it's keep on going down. Okay, so again this kind of examples also we see when we do the project, but this is just for your demonstration. Okay, all right. So there's another example I'm showing you now. Again, calculating mean squared error. Okay, again mean squared error I will discuss when we do the project, but right now I'm just deleting this part. Okay, because mean squared error and all we discuss when we do the project. Okay, all right. So this is the multiplication. Now let's talk about the further topics, that is modulus done, exponential done. Okay, let's talk about now comparison operator. So comparison operator is very easy to understand. Comparison operator is simple, it returns you true or false. Okay, this is the backbone of every uh, this is the this is the backbone of a if condition and training loop. Okay, so it always returns true or false. So you can see in the operator it got equal to, it checks two numbers are same or not. I mean, not only numbers, it can check for strings also, it can check for boolean also, but this is the example only for numbers we are showing right now. 5 equal to 5 means are they same or not. If they are same, true. If they are not same, false. This is a symbol of not equal to. 5 not equal to 3, true or false. Then greater than, then lesser than, greater than equals to, less than equal to. Okay, let's see in the example. You can see simple example, x equal to 10, y equals to 20, and simply we are checking x equal to y or not, x not equal to y or not, x greater than y or not, x less than y or not, x greater than equals to y or not, y less than equals to 15 or not. We are simply seeing this kind of examples. Okay, now some things I wanted to show you now, like let's say I got some marks, I got some score 95. Okay, and I'm checking the equality. So I am printing score equal to 95, score equal to 100. Again, score is equal to 95, they are same numbers. So I get output as true, and 95 equal to 100, it is not true. I get the answer as false. Okay, so if I execute this code, I am getting this thing like, you can see, true and false. Okay, again some comparing it with different types. Okay, again you have to keep in mind Python is case sensitive. Okay, now let's see, I am printing 5 equal to 5.0. so technically they are same, the data type is different one, it is integer, it is float, but Python treats it as a same. So it is saying true because integer and float can be compared inside Python. But if you check like 5 equal to string 5, it will become false. Why? Because integer and string are never equal inside Python. Okay, then if you check true equal to 1, it will work. If you check false equal to 0, it will work, because I have already mentioned in my previous videos that true internally in Python 1 and false internally in Python 0. Okay, then string comparison, like apple less than banana, docker equal to docker. Okay, again if you check, it is coming true, apple less than banana. Why it is coming? Because a comes before b, so it happens based on lexicographic or alphabetical. Okay, so that is why, because a is comes before b, that is why it is becoming true, apple lesser than banana. Then docker equals to docker, it becomes false. Why? Because Python is case sensitive. This is another example, Python supports change comparison. What does it mean? Like age equals to um, age equals to 25. And if I want to check 18 is less than equals to age less than equals to 65. So I am trying to check ki age is in between 18 and 65. I am trying to check that. So if you want to do this kind of comparison, right, chain comparison, you can do that too. 18 less than equals to age less than equals to 65. That means I am trying to check if the age value is between 18 and 65 or not, which is true coming up. Okay, then temperature, again same example, is it between 60 and 80 or not? This is the temperature. Okay, and also we can do like this too, 60 less than temperature, this is a separate part, 60 less than temperature and temperature less than 80. See, this and this are the same thing, it's just that showing in a different way. So if you see this code, right, you have to treat this code separately, you have to treat this code separately. So 60 less than temperature value is 72, 60 less than 72, true, and temperature less than 80. Okay, 72 less than 80, which is also true. So true and true becomes true as a final answer. That's what true is coming, but chaining is cleaner. Okay, if you want to do chaining like that, you can do this way also. Okay, now again some example that I am showing up, but this example I have used some comparison operator, but I just wanted to show you because it is a very good example. Like let's say you got your best accuracy 0.91, current accuracy 0.93, target accuracy 0.95, current loss 0.042, patience counter 3, max patience 5. What is this patient counter, max patience 5? Forget about it. It's just for demonstration. So I'm checking if current accuracy is greater than best accuracy. You have to give a colon like that, okay, whenever you write an if condition. So if current accuracy is greater than best accuracy, so if this condition becoming true, then only it will come inside this code, okay. Then it will print new best and it will print the best accuracy. So best accuracy will be the current accuracy. If the current accuracy is greater than the best accuracy, then we are checking if target reached. We are checking if current accuracy is greater than equals to target accuracy. So if this one becoming true, then it will print this, and if this one becoming false, it will come to else and it will print this one, okay. Same for check patience for early stopping. Again, what is early stopping we will discuss later, but for now focus on the comparison part. We are checking patience counter greater than equals to max patience, okay. So if this is coming as true, then only it will print this one, okay. The learning rate sanity check, this is the learning rate value that we have, and we are checking if the value lies between this range or not. If it lies between this range, it will print this. If it does not, it will print this else one, okay. If you execute this code, you will see all the answers, okay. I believe we are good with this. Okay, so now we talk about the logical operators. So what happens here? So we combine multiple conditions as essential for complex decision making in ML pipelines. So whenever we combine multiple conditions, right, such cases we use this logical operators. So I've already discussed about logical operators before, like the AND we used in the previous example, right. So there also I have discussed the same thing, but again, just to be precise on our discussion, let's discuss about the logical operator. So we use AND operator. So AND means what? So whenever you use AND, the scene must be like both must be true. So if you have something like true and false, right, it will return false. When you use OR, in OR case it means that at least one should be true. So true or false will be true. And if you use not, it inverts the value. So not true means false. Likewise, not false means true. Okay, let's see the below example. So this is an example of AND. So what I'm trying to check, true and true. Again, you can see the color of true and true is in blue. It means this true, this and everything is taken care by Python. It's inbuilt in Python. That's why again Python is case sensitive. So you have to write true this way. You have to write and this way. So true and true, it will be true. True and false, it will be false. False and true, it will be false. False and false, it will be false. Okay, as you know the rule for and all must be true. Okay, now our example. So true or true will be true. True or false will be true. False or true will be true. False or false will be false. So in our case, at least one must be true. And not means simple. Not true means false. Not false means true. Just execute this code and you will see the same output. Okay, great. So now let's do the short circuit evaluation. Important concept. So let's see with some examples. So AND stops at the first false. Why check more if one is already false? So you can think, right? So AND stop at the first false. So if that is happening, right, so we don't have to check the other stuff, right? So like let's say if x not equal to 0, x in our case is 0, right? So now I'm checking if x not equal to 0 and 10 divided by x greater than 2. Okay, so if you see in this example, so before explaining this example, let me show you something like, so if you do 10 divided by 0, what will happen? So if you do 10 divided by 0 inside Python, you will get like a 0 division error, because mathematically speaking you cannot divide any number with 0, correct? So you are getting 0 division error. But when we check this one, where we are checking if x not equal to 0 and 10 divided by x greater than 2, so in this example this condition is already false. X not equal to 0, which is false because x is 0, right? Because we are using AND, that's why it checks first this section. It will not come to this section directly. It will first check this condition, and as per our discussion, x is not equal to 0, it is false. That means it will not throw any error. Okay, if I execute this code, see, it is printing that short circuited 10 by x was never evaluated. So it did not come towards the 10 by x, that means 10 divided by 0. It directly printed because this condition became false. That's why it came towards the else section. It has printed short circuited 10 divided by x was never evaluated. So this is the one example. Whenever you use AND condition, right? So it always checks this one. It doesn't check this one first, because if this condition is becoming false, then it will not check this condition. So if this condition is becoming true, then only it checks this condition. So this is the example that I wanted to show you. So there's another example for OR. Like let's say username equals to blank. Okay, empty string, we call it as empty string, and then checking display name, username or anonymous. Okay, so if you see display name, username or anonymous, then I'm printing welcome display name, so it's printing welcome anonymous. Okay, so OR works on default values, if you see, because right now in my case username was empty string, right? So whenever you want to provide something default, like in this case display name equals to username or anonymous, so it has taken the anonymous. Okay, likewise username equals to Rahul. Now when I'm checking username or anonymous, it is showing Rahul. Okay, so you can see OR stops at the first true. Why check more if one is already true? So OR always stop at the first true. So that's why in this case, in this example, username was empty. Okay, so it did not found anything true here. It did not find anything true here, right? So that is why it came towards this one. It has printed that welcome anonymous. But for this example, username Rahul, so Rahul came here or anonymous. So it found Rahul at first and it became true. That's why it's printing Rahul now. It is not printing anonymous. Okay, great. Okay, now again this is a loop example. I will not discuss that one now. We'll discuss when we do the project. Okay, and when we do the further days. Okay, on that time I discuss about loop. So another example, let's say GPU available equals to true, dataset loaded equals to true, model compiled equals to false, config valid equals to true. Okay, so what we are checking? We are checking if GPU is available and dataset loaded and model compiled and config valid. So expecting if all became true, then only it will print all system go starting training. If not, it will print this. And if I execute this code, if you see the final answer, because GPU was available, dataset loaded was there, but for us model compiled was false, right? So that's why this condition this did not pass. It came in this condition and then this printing model not compiled and config valid. Okay, there's another example, checkpoint local false, checkpoint S3 true, checkpoint GCS false. We are checking at least one checkpoint source must exist. Okay, right? So I'm checking if checkpoint local or checkpoint S3 or checkpoint GCS, if any one of them exist, that means if any one of them becoming true, then print this checkpoint found. If not, print is no checkpoint found. And if I execute this code, you will find it is coming like checkpoint found, because in this case checkpoint S3 was true. That's why this became true. Okay, last example for this one, that is condition debug mode. So is production true? Okay, so you know, right, when I give not true, it became false. When I give not false, it became true. So when I think if not is production, so what is happening? Not true means false, so it will print this one, because is production is true, and if not true, that means false. So this condition is becoming false, so it will come to the else and to print production mode minimum login. Okay, so we are done with this section. Okay, now let's talk about assignment operators. So shortcuts for updating values you will use in every loop. Okay, so this is the assignment operator that we talk about. So you can see that we can do x equal to 10. If you want to update the value of x, what we do? Simple, x equals to x plus 5. If I do x equals to x plus 5, So we talk about this thing now. So you can see x equals to 10, right? So if you want to do add and assign, that means x equal to x plus 5. So if you want to update the value of x equal to x plus 5, that means x value will be updated. X value was 10 plus 5 15, so x value will be updated to 15. So instead of writing this way, you can write like this, plus equal to, that means x plus equal to 5. Likewise, same you can do for subtraction, same you can do for multiplication, same you can do for floor division, same you can do for normal division, same you can do for modular, same you can do for power of assign. Okay, so in all cases we can do this kind of add, assign, subtract, multiplication, divide, floor, all kind of assign operation. Okay, so let's see in the example. So you can see x equals to 100 and I'm printing start x. Then what I'm doing, x plus equal to 15. X plus equal to 15 means x equal to x plus 15. Again you can write this way also, no problem. But this is writing in a faster way. Or sometimes developer write code in this way so that you should know, right? So the x value would be updated to 150. Then I'm doing x minus equal to 30. So x value was 150 after this one. So then minus 30, that means x value will be 120. Then multiply equal to 2, that means x equals to x multiplied by 2, that means 120 multiplied by 2, 240. Then divided equal to 3, that means x value was 240. 240 divided by 3, you get 80. That's so you get 80.0. Why 80.0? Because we are doing normal division, that's why. Okay, then another example, x equal to 25, then x floor division equal to 4. So you know, right, 25 is not divisible by 4, but because it is floor division, we get the answer as integer, so we are getting answer 6. Okay, same 17. So you know, right, x, so x 17, and you know, right, 17 is not divisible by 5, so we get some remainder value. We are getting the remainder value as 2. Okay, then x equals to 3, that means 3 to the power 4. Okay, we get the answer as 81. Okay, so if I execute this code, you will see everything. See, start 100, x value become 150, 120, 240, then 80, then 6, then 2, then 81. Okay, so I hope you understood this section. Then another example that I will show you. Okay, so batch size 16, GPU memory in GB is 12. I am simply printing the initial batch size, then I am checking if GPU memory GB greater than equals to 8, which is true because this value is 12 and it is greater than 8, true. Then what it will do, it will multiply the batch size equal to multiply equal to 2, that means batch size was 16, so 16 multiplied by 2. Okay, and then batch size will be this, and if GPU memory is greater than equals to 16, and this is also true because no, this is not true, so it will not print this one. If I execute this code, you will see it's showing GPU has 12 GB double to 32, final batch size 32, because it did not print this one because this condition never become true. Okay, that's why. Okay, again this is a function example that I will not show you right now. I'll show you when we discuss about that thing. Okay, all right. We discuss about these two method, membership methods and operator precedence, then we can drop off our day. Okay, great. Okay, so now let's talk about identity operators. Again, these operators are pretty easy. Is and is not, it checks whether true variables refer to the same object in memory. So is means same object in memory, is not means different object. So it's like equal to means do they have same value, and is means are they the same object. So there's a difference between equal to and is. Equal to assume do they have the same value, and is checks are they the same object. Like here you see I have two lists 1 2 3 1 2 3. I am checking list 3 equal to list 1. So what I am saying, I have created a new variable list 3 and I have set equal to list 1. That means now list 3 value is also 1 2 3. Okay, list 3 points to the same object as list 1. Okay, so now when I am checking list 1 equal to list 2, it becomes true because I kept list 3 value as list 1 only. Okay, see list 1 equal to list 3, we got true for this case also. But when we are checking list 1 is list 2, we are getting false. Why? Because list 1 and list 2 are different object. Why different object? Because they are defined into different variables. List 1 1 2 3, list 2 1 2 3, they are different objects. Why? Because list 1 has 1 2 3 value and list 1 1 2 3 stored in a memory. Okay, list 2 is another value, is another object. I know list 1 value 1 2 3, list 2 value 1 2 3, they are same, but there is some memory allocated for list 1 as well as list 2. Correct? That's why they are two different objects. Here values are same, but they are two different objects, because list 1 is taking some space in your memory, list 2 is also taking some space in their memory. They are different objects, but the values are same, and that is why when we did list 1 equal to list 2, we got true. Why? Because equal to checks do they have same value or not. But when you use is, list 1 is list 2, it checks are they same object or not. It means are they stored in the same memory or not. They are not stored in the same memory, right? Because these two, list 1 list 2, taking a separate memory allocation. Okay, that's why it is coming false. But list 1 is list 3 is coming true. Why? Because I told list 1 equal to list 3 equal to list 1, right? That means this list 3 has not created any new memory for it. It is pointing this list 1 only. It is pointing to the same memory where list 1 is situated. Okay, and that is why it is the same memory. That's why it came as true. Okay, and then another thing, if you want to check id, if you call id of any object, right? So in Python, whatever variable we create, right, this all called as object. Okay, we discuss about object more, but this is the example: list 1 list 2 object. Okay, so list id list 1, id list 2 and id list, if we execute this now, we'll all get the memory value, like whatever values we created, right, variables we created, is all stored in a memory location, right? So this id will give us that memory id. So if I execute this code, I will get to know more about it. I will not show this example for now. Just execute this code. See list 1 id is 140 something, list 2 id is 140 something. See, they are different, the IDs are different because their memories are different. But if you see list 3 memory, see, its ID is same as list 1, because list 1 equal to list 3 equal to list 1. That means list 1's memory automatically pointed by list 3, because I did list 3 equals to list 1. That's why you can see the memory ID is same for both of this, but for this it is different. I hope this thing is clear to you, right? And there's some example. So there's something result equal to none. So if result is none, then print result is none. You can do equal to none also, but we prefer to use is. Okay, so that's the best way of doing it. Okay, so again, like you see, a equals to 256, b equals to 256. A is b is true because Python caches this. So if you see, Python caches small integers -5 to 256. Interesting point. So if you see, Python caches small integers. That means if you give any value between -5 to 256, it will take it as it will automatically take it as same values. Okay, so it caches the small integers. That's why when we give a equals to 256, b equals to 256, and when we did a is b, we got it as true. When we did a is b, we got it as true. Okay, then a equals to 257, b equals to 257, and when I printed this one, right, a is b, so now this will be false. If I execute, this become false. Why this became true and this become false? Because Python did not caches 257. Python caches minus 5 to 256. If you give anything between minus 5 to 256, then this is will always treat them as same. Python caches small integers. So from minus 5 to 256 treated as small integers in Python. That is why they treated as same. But if you give more than 256 or lesser than minus 5, it will always take them as different. That's why see, for this we got true, but for this we got false. Okay, I hope you understood this one. Okay, so now there are more examples that we talk now. So you can see null check in ML pipeline. So model equals to none, tokenizer equals to none, dataset equals to loaded. So what we did, if model is none, then print this and make the model value less than 50. If tokenizer is none, then make the tokenizer value as BP tokenizer. If model is not none and tokenizer is not none, print this. So when it will execute for the first time, right? So model is none, then it will update the model value with less than 50. Same happen for tokenizer. Tokenizer value is none for the first time, but later it became some value. It has some value after some time, right? So that is why at the end this condition will become true. If I execute this code, you can see model not loaded, loading now, tokenizer not loaded, loading now. Then it got values, tokenizer got BP tokenizer, model got resonance 50. So when I printed, I got this one. And you can see when I was saying if cached prediction is none, it called predict input data and it has printed the data. Okay, I hope this section is clear also. Okay, the membership operator. So membership means in, not in. So it checks if a value exists in a sequence. So it checks if any value exists in a sequence or not. On that time we use this membership operator. But I will not discuss membership operator because when we discuss about list or something, on that time we discuss about this member shifting. Okay. Then operator precedence. If you see, this is the operator precedence mentioned here. So the highest precedence exponent got the highest precedent. Okay, then unary got the precedence, like this it will get. So here I have mentioned which one will get the precedence, 1 2 3 4 karke. Okay, and you can see in live also. So when I am doing 2 plus 3 multiplied by 4, what do you think answer should be? As I said, you can see multiply got the third precedence and plus got the fourth precedence. That's why first it will do the multiplication. That means 3 multiplied by 4, 12, then plus 2 become 14. Okay, same 2 plus 3 multiplied by 4. Now because you see in this case, first this parenthesis operation will happen. 2 plus 3 5, 5 multiplied by 4 20. Example 2, before exponent before multiplication. If I do 2 multiplied by 3, then star 2. So you know, right? This is the highest precedence. So 3 to the power 2 become 9. 9 multiplied by 2 became 18. Okay. Then 2 multiplied by 3 become 6. 6 to the power 2 becomes 36. Okay. See, this is the output we are getting. Okay. Again, step by step example. This is a full example. 2 plus 3 multiplied by 4 star 2 divided by 8 minus 1. If I show you this and if I execute, see, first happened this operation. 4 to the power 2 become 8 16. Then step 2 happened, 16 multiplied by 3 became 48. Then happened 48 divided by 8. We got 6.0. Why 6.0? Because we did normal division. Then 6.0 plus 2 became 8.0. Then 8.0 minus 1 became 7.0. So the final output that we got, that is 7.0. So this is a one example how precedence works here. Okay, and this is another example without parenthesis. If you do true or false and not false. So and not false. Not false means true. So true or false. So true or false becoming true and true. So true and true becomes true. So if I execute this code, you will get the answer true. Now true or false. True or false, true and not false. True. So true and true becomes true. Okay, and if I choose a mixed operator example like x10 y5 z3, so result x greater than y, 10 greater than 5, true, and y greater than z, 5 greater than 3, true, true and true becomes true. Then x plus y greater than z to the power, sorry, z multiplied by 4. So x plus y become 10 plus 5, 15, greater than z multiplied by 4, that means 12. So 15 greater than 12, it is true. So you get the answer, true, true. Okay. And the last example in our case, epoch 45, loss 0.03, accuracy 0.06, patience count 4, max patience 5, max epochs 100. We are simply checking epoch greater than equals to max epoch. So epoch is 45, it is greater than equal to max epoch? No. Okay, that is false. False, or loss less than 0.01, loss becomes 0.03. Again, it is also false. False and accuracy greater than 0, so this become false. Why? Because this is already false and we are using and, so it will be anyways false. So false or false. Again, or patient count greater than equals to max patients. Patient count 4, max patient 5, 4 is greater than 5, no, false. So the answer should become false. Let's see, we got the answer false. Okay, and these are some quick reference cheat sheet that I have given to you, the few golden rules mentioned for you. So I hope guys, in today's video you have understood everything about Python operators. So I know I have discussed with lot many examples, and I have showed you few exception cases that no one ever have discussed in any videos. So I hope you have learned a lot from this video. We'll catch up next time. Have a great night. Bye.